Thomas. I'm the general delegate for the Méthatlantique. It's an association in the Pays de la Loire region. So there are 45 member organizations, mainly industrial companies, service companies, and we're interested in the gas production cycle. Our mission is to develop communication, representation, and to focus on members and competitiveness, and also in partnership with different international bodies as well as the regional authorities. So I'm delighted to be moderating this session on improving production costs. So we know how important this is for the gas sector to be able to control production costs of this green energy, notably given the pricing context, the digressive pricing context for biomethane as of 2023. So we will go through that pricing scheme in a while. So we're looking at 30% drop in prices. So this is what the sector has committed to achieving between now and 2030, which means that I need to point out something. You know, we've got a basic hypothesis. It's a very ambitious path that we'll have to follow. We're looking at low-cost methanization. The initial investment has to be taken into account, the capex. That has to be looked at. It has to be sized correctly in order to meet the use needs in the future. And then the user methods use very sensitive processes, quality, safety, operating practices are also some of the major challenges if we want to develop methanization in a serene manner. And can I invite you to keep some energy for the next conference, the next session at 4 o'clock, where we'll be talking about the professionalization of the sector, and that will be moderated by Armel Damiano from Elle. So we're going to be looking at future projects as part of the session. Most of the information on this webinar is also useful and beneficial for units, because each unit has to work on its economic performance while the purchasing contract runs. So just to give you an overall view and tell you about some of the past, some of the ideas being explored over the next few years when it comes to production costs. So we've got a panel of experts with us to talk about this subject. So to begin with, we'll hear from Jérémie PRIAROLLO from SOLAGRO, who will explain to us the key profitability factors to meet this challenge of lowered prices. So there will be 5 cases. Then we'll hear from Sylvain FRÉDÉRIC from GRDF, who will be talking about things from a strategic point of view and new energy systems focusing on methanization. So he will give us an idea of how the sector is getting organized collectively in order to adapt and structure itself for stakeholders in the future. Then with Maxime BRISSAUD from CH4 PROCESS, we will go right to the core of the machine itself. We will analyze gaps in terms of operation, especially electricity and maintenance. And then we'll hear from EcoAdapt, that was a candidate for one of the GRDF projects. So Mathieu Peterschmidt will explain to us why predictive maintenance has been chosen for an innovative solution. And then to finish, we'll hear from Moritz Quack, who is Vice President of the AAMF. He will draw a conclusion based on something carried out on his bioenergy site. So we'll finish with a session for questions and answers. So please ask your questions little by little. Please say who your question is for in the chat, and we'll spend the last 10 minutes going through some of those questions. So without further ado, I'm going to ask Jérémie PRIAROLLO to put his camera on and get ready to talk to us about the key factors for projects that want to benefit the new prices. Yes, hello. So Jérémie PRIAROLLO, I'm in charge of the methanization project. I'm in charge of the methanization project. As part of the ecosystem of the sector, our job is providing independent consulting, help with project management in local areas, but also carrying out prospective studies on the subject of methanization. Now, as already reminded, we've got some new prices for biomethane that come into force in 2023. So this is going to have a big impact on units. This we don't want to deteriorate the projects because of this. So there's an impact study that's been carried out, an economic impact study that's been carried out, and drivers that can be used for financing and work with banks. An analysis has been carried out to identify different drivers that can be activated so that we've got the right kind of profitability and so that we can work on bank debt. So optimizing methanization requires different drivers. So without any kind of breakthrough technology, we've got to decrease investments via CapEx. We've got to decrease costs, so OpEx, or increase revenue. These drivers can be complementary. There's no exclusivity. So coming back to investment, therefore, the drivers are optimization of sizing. The lowering prices will have an effect on the digestion system and the organic waste and the load, so no more than 5 kilograms per day, sometimes a little bit less. And it's important, that the number of days is counted as well. 70 days for projects of less than 200 cubic meters per hour, but we need to have new concepts and new designs, so monodigesters and cogeneration. So there are also purification systems that can have effects. So the compressor, for example, that increases the capex of the project. So it seems opportune to encourage suppliers to have a bigger stock of replacement parts to limit redundancy while maintaining availability, high availability, which is of course essential. With decreasing investment can also be about relocating a digested stock. So this has become more and more democratized. This storage can be of two types, either small pockets close to spreading areas, or large volumes in major areas, so on major sites. So one of or the other. So the third idea is to focus on standardization for the sector, even if it's unlikely that all budgets will be going down in the future, because there's an important share linked to earthworks, concrete, electricity, electrical works, all of that might go up. So it would be good to optimize process costs, engineering costs, thanks to the development of the sector overall. It's also as part of this reduction in capex that we can imagine having calls for tender that are grouped, that focus on consumables and electricity. Now, coming to expenses. So something that has to be handled with care is the optimization of the purchasing cost of intermediary energy crops in a context where these surface areas are going up. So on these surface areas, we have to cover the soil, cover the land, and perhaps in these areas, we need to work on a case-by-case basis and look at an optimized price with respect to non-harvest areas. Also, for decreasing costs, you can have solar electricity self-consumption. You can have, for example, a farm building with solar panels, so electricity generated for the needs of the site. So this is not always relevant because some installations don't always consume electricity. So the purifiers always consume the same quantity of electricity. So for revenue, it's possible to retrieve biogas from the digested storage ditch. We can also invest in a sealed cover so that there are savings there. Generally speaking, when I say raw digester, these are not covered by a gasometer, because aside from a gasometer, you have to have a liner on the cube to protect the digestate. The height of the digestate can vary in the tank, and so in this case, it's important to protect the whole height of the tank. So in this context, we've studied floating covers, because this means that we don't have a liner and that additional cost. So increasing revenue, this might mean over-insulating the digesters so that there isn't no additional thermal consumption. So we've got to limit thermal loss, heat loss. So we've got to have some kind of a cover, a 16 centimeter cover. Something else that needs to be looked into is the sale of digestate. We've got to make sure that the digestate reflects its agricultural value. So we only count on part of the digestate as well. It would be over-optimistic otherwise. So if we just take the manure waste, for example, that's not good, because there is an exchange, because there's a share of nitrogen that is mineralized during the digestion process. So there is a mineralizing gain that can be used and sold. So another avenue concerns, look at the bio-CO2 and what we can do with that. So we could invest in a bio-CO2 purification system to liquefy it, to purify it, and sell it on the market. To the steelworks, for example, so with 50 to 100 per ton. So this bio-CO2 can be produced and used, therefore. So these are possibilities that are being studied today. And a last driver is based on improving the operation of the sites themselves. So there, the idea is to improve availability in order to maximize revenue and operating efficiency. This means better monitoring, better checks, better controls, and we'll see more about this in the coming presentations. Now, to understand the impacts of these different optimization points, we've worked on some standard cases. So with ratios, investments, load, revenue, so different standards concerning inputs, technology. So number one, for example, this corresponds to 11,000 tons, diversified application, with manure. So with, you can see the amount of methane that would be injected, 1,400, and a project that without a subsidy, in conditions of the purchasing price, well, if we signed the contract in 2022, it's not at all feasible without using some kind of driver. So this is a basic project, but we can test different drivers using this project. The second standard case, 24,000 tons this time, so 120 cubic meters in terms of injection. So we've got different types of manure, different types of animal waste. So think of the scale. So we've improved things. We've got internal profitability from the invested capital. In this case, that's another driver. So case 3, 36,000 tons. So this is the limit of our authorization, with the half liquid manure, half intermediary waste, with injected gas, again in liquid form. So at 4.7%, the result is better. So this is another case now with a liquid manure, 200 in terms of injected flow. We've got no premium linked to the intermediary energy crop, so it's just manure. So we're losing 2 points in relation to case 3. So it's only 2.5% for case 4, and then 5, 26,900 with continuous solid process. So, and before subsidy, before the drivers, we're looking at something that's much more profitable, 7.8%. So these are the different cases that were tested. So for these different cases, so again, we've simulated the economic aspects relating to biomethane for 2020. So we've got the taking into account the degressive pricing system with equity at 7% and a banking loan over a certain number of years and an 8% interest rate. So for the different types. So next slide, please. So once we've tested everything, so the 12 drivers that we worked with for the 5 cases, so we've got this kind of diagram that positions each driver on an axis. So we've got the impact of on the TRI, and we've got the impact of the driver on the capex, on the investments, whether we're talking about something that's positive or negative. So the area covered by each driver depends on the amplitude of the financial impacts of each axis on the different standard cases. So according to the standard case considered, the project, we've got an impact that can be positive or negative, more or less advantageous or not. There are certain drivers like use of insulation layers or a gasometer. So that's quite close to the intersection of the two axes. This represents a low investment. There's little capex, so this means a better TRI, but as the return time for this investment is 3 to 4 years generally, according to us, it's advantageous. It's a good idea to use it to have a more sober installation in terms of energy use, so it maximizes its energy efficiency in terms of the gas injected into the network. So it's not a driver that would alone allow for something very profitable, but it's one of the components of a more relevant kind of project. So economically, it's advantageous. So there are other drivers. So a gasometer in the digested storage ditch, for example, this takes up quite a big room. It has quite a big impact. So using a gasometer is positive for sites that already are equipped with a storage tank made of concrete. For sites that have a phase separator and that store liquid digestate, the effect can be negative because the area goes towards the right, and that has a negative impact on the overall efficiency, the TRI in French. So if there's a phase separator and a big bag, this isn't compensated by the production of gas. So there's a negative impact. So in the case where you've got digested storage in a ditch, then clearly this is a driver that can be explored because it has a very good effect apparently on the efficiency of the project. Now, setting up a building with a solar or photovoltaic roof, so it's a self-consumption here. Now, it finances the cost of a building of 700 cubic meters. So it controls part of the purchasing costs of electricity consumed. So we're looking at 20% of autonomy in terms of electricity if you're installing a 100 kilowatt peak power. So this is something that can provide a certain amount of autonomy for a project. So right at the top, the sale of bio-CO2. So this uses an awful lot of capex. So it has a very strong impact, almost 100,000 euros. It has a significant positive impact on the economics of the project. So it's more for bigger projects with more efficiency, positive efficiency, but it's not something that can be done everywhere. You'd have to have a bio-CO2 consumer. And as there's no real scale effect for this investment, it's advantageous for big projects, so 80 to 120. So it has a negative impact here because the financial gain in terms of revenue doesn't offset the investment of the project. Now, dropping the occupancy time limits the digested volumes. It allows to limit the amount of equipment. The optimization has a very positive economic impact on projects. But of course, the installation will not be easily upgraded in this case. So we haven't applied this optimization for case 5. Case 5 is a continuous solid process. So for the other cases tested, it has an impact which is +1 or +3 points in terms of economic optimization. So setting up flexible bags, this has a positive impact. Again, it has to be customized. So, you have to look at the driver on a case-by-case basis. So using flexible bags, these cannot be combined with the setting of a gasometer. So you don't need storage with a phase separator. So it really depends what other equipment you're using. So you can't really add things up one after the other. You have to make choices, but when it's possible, flexible bags help with transport, help with spreading, and help with the economics of the project. So the sale of digestate, that's a real optimization enabler. It really offers gains, but it requires the presence of something that is sustainable. You often need to move the cursor because we're talking about savings for farms, but that you have to find the right balance. It's something that needs to be handled with care, but and studied on a case-by-case basis. So you've got to look at the cost of the intermediary energy crops as well. However, for us, it's necessary for us for farms to be encouraged economically to set up these intermediary crops, especially if they want to move towards a high development of methanization. So it's a driver to be handled with care. If it's possible locally, it might be good if it's logical for the project leaders. So operating the sites properly, this represents a very big challenge. So we were very careful in our study with this criterion. Because the financial impact can be bigger, it's good to anticipate what you're doing, like the AMF does or other stakeholders in the sector. It's important to raise awareness about the challenges of the operation of a methanization unit. You've got to have control of gas leakage, for example, and other aspects. So that's a kind of overview of all of the different enablers or drivers in terms of investment and efficiency. So just a couple more minutes. Yes, certainly. So this is a summary table of the different drivers that can be combined. So it gives us a debt coverage that is above 130%. So this can satisfy banks. The DCSR is the relationship between the BE, the excess, and the reimbursement of the debt. So it's the ability of a company to have an operating margin that is big enough to cover its borrowing. So if it's 100%, it means that even if the expenses and revenue are different by 30 points, the project can continue because of the time to pay back the loan. The good news is that it's possible to have financial feasibility for all standard cases. It doesn't matter what kind of cubic meters we're talking about. So we've given priority to the most realistic drivers, the simplest ones to implement. So this is we've got 8 drivers for small projects for 80 NMR3 per hour. If it's not possible to achieve 15%, it's better to look at sale of digestates or look at how to use intermediary energy crops, or the use of external funds so that there isn't too much payback time for the loan. So for 250 NM3, we're looking at 8.6% in terms of efficiency. So by playing with the different parameters, you can find the right kind of efficiency. So we've talked about sale of digestate. but this has to be analyzed on a case-by-case basis. It's very theoretical. So we haven't applied any ADEME subsidies or regional subsidies. This would mean adding a specific factor. So you can have combinations of enablers to provide profitability for the different standard cases analyzed. Some enablers, some drivers require additional investments and therefore more equity. That's why it's important to look at co-financing solutions with participatory funds or institutional funds or even private funds to diversify the situation. And then there are enablers that involve all sector stakeholders, design offices, etc. Everybody is involved in the activity. There we are. Thank you, everybody. Thank you, Jérémie. Thank you for shedding light on that situation. So these are ideas that should be investigated further. There's a question about performance.
Oui, bah, il y a effectivement beaucoup plus de livrables qui ont été aujourd'hui restitués.
There are more deliverables today. We can imagine more specific meetings to share results. That's the idea. You know, everybody needs to be involved. The sector needs to progress together with all of the stakeholders. Thank you very much, Jérémie. So we'll come back to you at the end of the session for the questions and answers.
Thank you very much, Sylvain. And thank you for enabling us to take a kind of helicopter vision on what's going on. Are you able to hear me? Yes. So my name is Sylvain FRÉDÉRIC. I'm in charge of R&D for biomethane for GRDF, and I'm co-pilot as well of GT industrialization with Grégory Lanoux. So I've worked on industrialization, and I'm going to present to you the work that is pretty complementary to what Jérémie has presented, all of the different types of leverage or levers that can be activated. And what I'm now going to present to you is the medium-term work on how our sector can potentially get organized in order to have full mastery over its production costs. So very briefly, let me go into detail on what the Sector Strategic Committee is all about. Since May 2019, we've had this committee in place, and this has been formalized by the signing of a contract between the biogas and methanization sector and the state. And we have a certain number of commitments regarding how we can monetize the externalities and also all of the different efforts we can make in terms of innovation. Within the scope of this, we have a working group, a specific industrialization working group that aims at structuring the sector through innovation, looking to guarantee competitiveness. And we're looking to find tangible pillars that will enable us to invest and know what we're investing in. Now, this industrialization working group is open to all of the methanization actors and all those actors who would like to contribute to the building of this work. There are many actors who are already involved, but it's a very open-ended organization. So anybody else who would like to join can. To move on, why is competitiveness so important? Why is innovation important? Well, because we've got over 8,000 production sites for biogas in France at the moment, but there's a massive queue as well. There are people banging on the door, literally. There are over 1,000 projects for gas injection. On the right-hand graph, you can see all of the different projects for injecting gas in what we call the waiting line. And yet at the same time, we still need to improve our competitiveness because the authorities have now stated that they will only provide funding if we can guarantee the efficacy of our production. Between a 20 to 30% reduction of CO2 emissions in relation to what is sent out into the atmosphere at the current time between now and 2030. So for this, there's already been a study that has been conducted in 2018. MEA and ESTRAD carried it out, and they basically looked at the short, medium and long-term aspects for the methanization sector. Mainly what they focused on was what cost reductions were possible regarding the entrants, on the valorization for biogas, but also on the standardization of the different methanization units. So in relation to all of these different levers, the idea was to select just a few of them to then attempt to structure our specific sector. And within the scope of our working group, we've decided that because we've got access to all of the information, we thought it was important to focus on 5 forms of leverage. The first one concerns the entrants. We've looked at this, and Jérémie highlighted the following point very clearly. If we have lower production costs, and if we have yields that can be optimized in terms of the entrants, then immediately we have a higher return on investment. So basically having full control over the cost of the entrants, this is something that is absolutely vital. We realize today that this is the main pillars that underpins the work done by our working group. The second point, once again, it concerns the entrants, and it's how we can compare the different pre-treatments for the entrants. We know full well today that we have several possibles for increasing the methane content. How can we compare all of these approaches, and how can we analyze the performance of the different pre-treatments? Another form of leverage that's important, it concerns the maintenance work done on these units and the training provided to the operators. We need to look closer at the different training sessions that are provided for the people in charge of maintenance and operations. There are all kinds of guide and reference documents that can be referred to. And next, when it comes to the biogas and CO2 management, as Jérémie said, we have quite clear ideas of how to valorize the CO2, but we need to structure the different actors further so that supply and demand, or rather demand and supply, are managed in the most efficient way possibly. The technology is relatively mature, so this means that now we can valorize CO2 from these methanization units and sell it hopefully at a decent price. Here on the screen, you have just a few deliverables, either documents that have already been published or that will be published over the next few months. As I said earlier, for us, it's very important to ensure that we have a good sound catalogue of the different training offerings that we're able to provide for methanization, for operating the methanizers, and for maintenance work. We also have what we call professional documents on all of the specialized fields. It's very important in these methanization units to identify what the clear needs are in terms of the skill sets, so that the secondary schools, the farming schools, and all the different training schools realize exactly what kind of know-how is necessary for the people who come and work at these methanization plants. Also, we want to make available to the whole sector all of the decision-making tools when it comes to working out how to recover CO2. We've got the Excel file in the top right-hand corner, and this provides you with a comparison of the different solutions concerning the pre-treatment process and also concerning the entrants. And what we do is map out to a certain extent the different types of biomass, the different biomass flows, and the directories, the marketplaces as we call them. These are the marketplaces, of course, that have legal obligations also to structure their sourcing of the methanization units. Now, another point I wanted to stress was an approach that is underway. It's a cross-cutting approach that we share in our different working groups, whether it's for valorization from CO2 to biogas or the entrants. We basically want to highlight the approach that is called the design to value. There are other sectors in the automotive industry and the nuclear industry that have used this approach, and also a certain number of companies have applied this, and we're looking to apply the design to value in the methanization industry because it enables us to valorize and showcase our product, to guarantee that we structure everything we do more successfully. So through this industrialization phase, what we want to do is to enhance the democratic nature of this approach for each of the actors. We're basically saying we've currently identified that there are lots of levers out there, but maybe you, the actors out in the field, the OEMs, or all of the people who exploit and run the methanization plants, you too can think about your own ways of reducing the production costs. And in order to implement this approach and to guarantee the democratic nature of this approach, we work with Utisa. Utisa is a firm that is specialized in design to value approaches. It's basically all about value analysis. And so what we're doing is we're giving access to this approach via webinars, online conferences that last for 2.5 hours. There are 8 of them. You can sign up for a conference. You just type methanization and Utisa on Google, then you fill in a form. The initial sessions are already full, but there is still 8 remaining sessions that you can sign up for. It's open to anybody and everybody. It's totally free of charge. And it means that each actor who is interested can basically buy into this kind of approach to the sector. There you are, Mickael, that's all I wanted to say.
Voilà, merci beaucoup, Sylvain.
Thank you very much, Sylvain. Just a quick question concerning design to value. What about the training courses? You said it's open to operators, to professionals who work in the sector, people who work in the construction sector. Have you got typical profiles? Yes, maybe I was a bit too quick. I only had 10 minutes, so I didn't go into detail. Who are the main actors for whom this design to value approach is valid? Well, it's mainly those who build the methanization units, the OEMs, the design and development offices as well, that can be very interested in this approach. Also the operators, the project owners, because all the questions in these training sessions can be very relevant. It's important to optimize the project products, whether it's the CO2, the methane, or the digestate. And the same is true as well in terms of the costs and in terms of cost reduction. Personally speaking, I've been working in the methanization sector for the last 15 years. And when I meet the operators, that's the main concern that they naturally have. So we might ask ourselves, why on earth are we looking to set up this approach? Well, it's basically because this approach is a structured approach and it enables us to capture all of the feedback from the companies who are highly specialized. At the end of the day, we've got something that is more structured, more organized, and will make far faster headway from an economic perspective. Yes, we could do this work ourselves, but it would take us a lot longer if we did it ourselves. It's much better to have a structured approach whereby we adopt the design to value methodology. And we're working with ESA because we've worked with them in the past, and it really does enable us to enter into this approach efficiently and quickly. Okay, so all the information will be made available alongside your presentation, and Grégory Lano in a webinar already, he talked about these training courses, so I can imagine that the training courses will suddenly be chock-a-block, so do make the most of it if you wish to sign up. Yes, I repeat, if people would like to sign up, we can open up other conferences online if we have too many people interested. Thank you very much. Okay, let me now pass the floor over to Maxime BRISSAUD. Can you please turn your camera on and your microphone? And we're going to focus on several methanization sites so that we can basically get our hands dirty, virtually speaking at least. Yes, good afternoon, everybody. Welcome, Maxime. So I'm going to be talking about CH4 process. I've got 2 slides just to very briefly explain to you exactly what we do. Yes, we are specialized in technical science, in operating the sites and in manufacturing specific machines. We're present in the northern part of France, but we work throughout the country. And what is specific about us is that ours is a social and solidarity-based company. So in our articles of association, we have a list of best practices that we have to stick to in terms of renewable energies in the biogas sector. So we can work, for example, on a wide variety of sectors
d'études techniques, prestations
We can
intellectuelles.
work on technical analyses, on site interventions, the sites that are up and running in different areas where certain specific types of work need to be done. We do a lot of research work looking for gas leaks or looking to see why a unit is broken down. We can also manufacture specific machines for washing, drying, managing pressure in the context of biogas. We also have another specific feature is that we propose all of the tools that can be used for performing the analysis. And so we've set up a brand so that we can manage all of the trading part as well for consumables. If you have any needs in terms of analyses on consumables, it's not our main target, but we have a certain amount of know-how. So that's what I wanted to say by way of who and what we are. Well, why am I speaking today? It's because we're working with AAMF and GRDF to work out whether or not it's possible when it comes to optimizing the cost of the installations to work with specific specifications so that as many design and development offices as possible can intervene to see how we can make savings on the maintenance costs and how we can make savings on the electricity consumption side of things. So work has been done to draft standard specifications so that the operators can consult design and development offices, and our work was to test the solution on 2 sites to see whether the specs live up to their expectation and whether they actually help. What is important before we go into detail either on maintenance or the electrical consumption, what's important is to prepare the audit sufficiently. When we work at the different sites, we've realized that often what's important, first of all, is to spend time collecting information. This can take up an awful lot of time, and for an operator, before they call people to come and work at their site, we say it's a good idea to gather together all the documents that might be of use. All of the information, all of the data has to be up to date. The electrical diagrams, for example, the prevention plan is important. If we send somebody to your site, you have to provide them with all this information. And if possible, it's good to give all this information in advance, sending by email. Why? Because all the work that can be done over the phone beforehand to prepare the intervention on the site, well, it simply saves on time. And it means that when we arrive, when we get to the site, we're not discovering everything. We've already got a lot of information that we've been able to prepare. I stress this because this is a point that is often neglected. An audit is a good audit if it's well prepared. Next slide. Concerning the maintenance aspects, let's have a look at the initial operations that we've been able to carry out. First of all, we identified the critical equipment. There are different ways of doing this. We, for example, used the pure method. It means that when you visit different sites, for each type of equipment, you can allocate a score, and that way you see whether the equipment should be considered to be critical, ordinary, or non-critical. There is a grid, an evaluation grid with a certain number of points that can be used. You can see how important the equipment is, whether it's likely to break down, and the degree of wear. So we basically adapted this method to methanization, the aim being, of course, to be able to analyze all of the types of equipment at the site, and the aim also being to work out what the critical and non-critical machines are. So what is the purpose, the underlying purpose of this? Well, it enables us to know where the maintenance work needs to be done, because either you've got critical equipment and you can do what needs to be done and protect it as critical equipment, and you can work out, for example, what are the redundancies that can be used. How can you potentially replace this equipment to make it less critical? You can also think about the impacts of the equipment in the case of a breakdown. These are the objectives so that we can switch a piece of equipment from being critical to being ordinary. But above all, we focus the maintenance on setting out a list of priorities. In other words, for the critical equipment, we need to make sure that the spare parts are available and with all of the protection formats that are necessary, and we have to have the right tools to intervene. Basically, it simply guarantees that for the 100 or so types of machines that you might have at a site, we need to make sure that we know which ones are crucial. And it means that there has to be regular inspection of the different machines, and the less important machines can be inspected less often. So that typically is what we do in terms of the maintenance operations. There is also another part that is quite important. This is something that we did. We entered into discussions with the operators. You might say this is complicated because we interviewed them for an hour or for 2 hours. So as you can imagine, the interviews were quite detailed. We had a whole range of questions on a questionnaire. There are 2 copies on the next slide that we can look at. But basically, thanks to the grid that we've got, we were able to work out for each question what was normal, what was the state of the art, and what would be the best next case scenario, and where potentially are there danger zones. This is why, for example, as you can see, if it's 0, it means that there's a hazard. Basically, the greener you are, the better you're doing your job, or rather, the better the installation is. We did this grid with 6 themes, from predictive through to corrective maintenance, and we focused on those machines that are not as safe as they could be or that are sub-optimized. And so overall, it means that you end up with a diagram like the one on the right-hand side that gives the operator of the plant a clear idea of the areas where they can improve and where they're doing a very good job. Here you've got 2 examples of questions. One concerned the inventory of spare parts. We asked the operator how they manage their spare parts. Do they have a follow-up document, for example? Do they know exactly what spare parts go with what piece of equipment? And also, there are many obligations from a regulatory perspective, and can they guarantee traceability in the case of an inspection? Can they display that everything has been done on time? So every single time we have a question, and then we have indexes that enable us to know whether we're doing what we should be in relation to the state of the art. And that way you have a great snapshot of how the plant is doing and what the recommendations are for improvements. In terms of the recommendations, you can easily have a situation whereby you say, okay, it's urgent to solve certain issues, and then you can have an impact grid, and you can stipulate whether we're going to be able to make a saving of €1,000 a year, for example, by changing one piece of equipment, or if the action costs over €1,000 and is not essential, well, you can work out that there's no point entering into that action. Basically, it's important about creating the right balance in terms of the actions you plan to take to improve the efficiency of the plant over time. So identification of the critical elements does enable you to work out where to focus the maintenance, and then the recommendations that we make, thanks to this questionnaire that is very structured, enables us to list the categories and the priorities of the different actions that need to be taken. The savings or the gains can be direct or indirect. Of course, it means that you can perform preventive maintenance before having to repair solutions. Corrective maintenance, obviously, is what you do after the breakdown has taken place. And it goes without saying that preventive maintenance is always cheaper than the aforementioned. Machines never break on their own as well. They tend to break the machines around them too. Obviously, you've got the staff that are on duty, staff that sometimes can be under stress if they work on complex machines. So the idea is also to simplify the staff's job wherever possible. The shutdown or the downtime of the different machines can sometimes be reduced. And it's possible for us to help the operator work out what kinds of parts absolutely need to be in stock. And sometimes you can have grouped purchasing processes with the operators of other plants. All of this is all about maintenance to avoid breakdowns, or to say if there's a breakdown or if there's an accident, if something goes wrong, it's possible to make savings and to function as a group. That's what I wanted to say about maintenance. Let's now talk about the electrical part. Here you've got an initial analysis that is very much based on the invoices themselves. If we look at this specific case, we were able to identify excessive use of electricity, and we were able to see that 250 kilowatts was supposed to be used, and in fact 280 kilowatts was being used, and so €800, not including VAT per month, could have been saved. This is quite considerable because depending on the contract that was signed at the beginning of the project, and sometimes it was way off reality, well, you could either have subscribed to a high electricity output and you might not need it, so you're paying for nothing, or you don't have enough electricity supposedly to be provided under your contract and you pay penalties. This is excellent because it enables you to see maybe if you've got machines that start up that come on at the same time, whereas they don't need to. You can work out what your electricity need is based on the invoice, and when you sign up for your contract, you can make sure that your contract corresponds to the real needs that you have. There's another aspect that is important, very easy to look at. It's the CSPE, whether you can be exonerated in France, whether you can be exonerated or not. This, in fact, the CSPE is a contribution to the public electricity service, and those units that produce energy can be exonerated from it. It's important to be very careful because when you have methanization related to a farming activity, only a percentage of what you produce can be exonerated. So when you've got a single contract and when the electricity is used by the farm and by the methanization process, you need intermediate meters to be able to make sure that nobody can criticize you for feeding too much methane into the grid. So the subsidy is easy to obtain because you just have to make a declaration and fill in a document. And this can have quite a major impact if we look at the next slide. We can see how important it is to have the right contract because in orange you can see the moment as of when the operator asked to not have to pay the CSPE, so they make a saving of 600 to 900 euros a month. And then in the right hand graph you can see when they increase the amount of energy that they use. So on the left it's all the euros per month paid for energy consumption, and on the right it's how the amount is distributed from 0 to 100. And we can see that the orange share, the CSPE, leaves quite a lot of room over the first months, and then it turns to red in the middle of the graph. But this disappears pretty much once you've changed your contract. So these are two ways of adapting so as to make considerable savings. I repeat, this is why you need to check that you've always got the right contract. Your electricity contract has to be fine, not only during the startup phase of the unit, but 3 to 5 years later, you might need to ask yourself the question, should you change your electricity contract? The rules might change, your consumption might have changed. It's all important. So we also performed a certain number of electrical measurements. This was much more focused. Here we could measure the energy consumption. We've got cases that record the consumption by different machines, and we measured the cycle for each of the machines, the effective power, the installed power, and also the intensity at the different phases. That way we were able to identify where there were any gaps. The problem with this is that you need a reference framework. In other words, how should the equipment normally operate? We also checked the balance, the energy balance. This is something that is sometimes more complicated. What we were looking to work out was how consistent is the site's energy consumption. You take into account the startup phase, the operating phase, and the shutdown, and you work out whether all of this is consistent. This takes a lot of time, just the setting up of the electrical measurement equipment, and sometimes you have to stay for several cycles to work out your figures. And when you see how many shakers, pumps, stirrers, pressure units there are, as you can imagine, this is the kind of measurement that takes up a lot of time. So for our initial approach, we felt that maybe it was a bit of a luxury to perform these measurements in a detailed manner, even if it gives you a very good snapshot of where the energy is used. But at least for our very first audit, we thought maybe this isn't where we're going to find the biggest discrepancies and the biggest impacts. Let me now show you just a few examples of what we did find. Prior to this, we focused on the different types of IE motors. I'm not going to go into detail on this because this isn't something we chose to focus on in the specs. Initially speaking, we said, well, motors that are not IE 2, 3 or 4, should they be replaced? Will we be able to make major energy savings? And in the end, we said, no, an engine that works, a motor that works, why change it? But when the maintenance team arrives on the spot and when they're looking to potentially replace the motor because it's been damaged, then it is important to stress that you need to have the highest category possible, i.e. 2, 3 or 4. And for those who are still looking to design a site, it's important maybe to pay a little bit of extra money that the builder will request for an i3 engine, because the impact on the site will be quite major over the years. The impact will be quite major, but it's not sufficient to say we're going to change the motor, replace it if it's already up and running. Okay, just very briefly, we have a certain number of examples of anomalies or areas where we could optimize what we do, thanks to the maintenance analysis, but thanks to our analysis of the electrical consumption. We noted that in 2 sites, 2 of the stirrers used a massive amount of energy, and that particularly during the startup phase, they consumed a lot of electricity. This can come from the fact that they've been poorly adjusted at the level of the speed drive. It can be due to dirt that has got into the vat, but basically this simply enabled us to say very clearly, these 2 stirring devices are the first 2 things that are going to break, so that's why they need to be monitored. Next, there's another point that was quite interesting, and this was worth several thousands of euros potentially, or even more. We were able to observe that the gas condenser used too much electricity, and when we looked very closely, we realized that one of the safety valves, the pressure safety valves, was leaking. And once you've got a safety valve that is leaking, well, you have to work upon the leaks. And we saw that we went from 76 to 72 kilowatts. So hence we avoided part of the gas from being lost. This is an important issue because if you're able to analyze the different types of energy consumption and what is not normal, you can make savings directly by correcting things. We basically used we could have used an infrared camera, but what we often see is that there are leaks from these outlets, these safety valves, and you can't necessarily send in an infrared camera, not into the hot gas anyway, but you can still potentially have the problem. This was interesting, quite an unusual problem, but it's the kind of thing that we identified as being a potential problem.
And then we can have clogged filters. So this is on sites that are over 5 years old. We've identified that load loss, so over 20 millibar. So in terms of the overpressure and the compressor, there's a kind of overconsumption. And so we thought about changing the exchanges, replacing them, having plate exchanges, and with a clogging that cannot be dealt with. So on the 2 sites, we were able to identify this problem and that we had to work on load loss. And we also saw that on one of the sites, we can optimize regulation because the overpressure had a set point that was very high, an overpressure set point, and there was several millibars too many. And so we suggested to the farmer to change it and to have something lower so that we weren't compressing or over pressurizing. So that's just one example. It's between 600 and 1,000 euros a year just to change the setting. So I've got a few minutes left. So if there are any questions or remarks, I would be happy to take them. Thank you, Maxime. We're going to move on to the presentation, next presentation, but just let's come back to the CTBM. So a lot of work has gone into the study, so well done. And so you're going to circulate that information. It's going to become a best practice so that it can be more generally shared. Well, we have to see with MES how they want to, circulate the specifications. It's true that it's not really best practices identified, but specifications, questions that need to be asked. What we're seeing, and I'm kind of preaching for my own parish here, we suggest maintenance operations there's always something to be changed, some kind of setting, and you can save 1,000, 2,000 euros by doing this. So the advantage of not circulating this information is that you can find people to be able who can actually do this job. So with studies like this, the objective was to stay below 5,000 euros, to target 2,000 euros. So these are studies that normally cost between 2,000 and 3,000 euros. So to come back to C2Es, there can be investment support. It really depends on the type of motor, i.e. 3, i.e. 4, but it means that you can pay for 1/3 or half of the price difference, but you've got to be accompanied by somebody who is qualified. So this again is something that happens quite often in the industrial environment. So it's not very much applied to methanization. Not very often. It's not something that it can be seen very often. So, and then there's what Alice was saying. They're not always accessible, these. So you have to start. I've already done this for cogeneration, but it was 5 or 6 years ago. Thank you very much. We're going to move on to the next presentation now. And I'm going to ask Peter Schmidt to come and join us. So it was EcoAdapt that put forward a project as part of a corporate project. So Mathieu, thank you for coming and being present. So we've got 10 minutes to just to explain to us what this EcoAdapt system is adapted to methanization. Thank you, Mickael. So as Mickael has said, EcoAdapt answered a call for project a few months ago and was selected. We were winners. So it was a predictive maintenance project. So EcoAdapt, we were born 8 years ago. We're a Parisian company with about 15 people. We work in IoT. So we've developed a first solution. So that was a few years ago, based on supervision of consumption of energy and the quality of installations. That's what you can see on the left-hand side. And now we're focusing on predictive maintenance. So we can move on to the next slide. So why predictive maintenance then? And in particular, why machine predictive maintenance? Well, I was talking with Maxime about this. There are a certain number of machines that are critical in installations. It's true for biomethane installation, but it's also true for trains, wind turbines, installations where you have public escalators, for example. All of these machines, when they break down, that creates many problems. And on the next slide, we can see some of the figures based on a wind farm. So there's usually very good availability, 97% availability. So 97% of the time they are running, but there is time where there is a wind turbine that is not working. And there are a certain number of unplanned events, so generating different emergency actions with parts that have to be changed. And this means that electricity cannot be produced. So if we transpose this problem to biomethane, similarly, there are going to be a certain number of machines that are critical and others that are less critical. So there's a matrix that was presented with the machine criticality just before. So it's a good approach to have, to know what machines are critical for your operation, the ones that are going to cost the most to repair. So this is what EcoAdapt is focusing on with its solution, its PredictAdapt solution. So the idea is to use electrical signals in order to make the prediction. So we can all remember three-phase power. So this is something that you lose, that you learn about when you're at school, if you do technical studies. If we click again, we can see what's happening. That's the theory on the left. And in reality, this is what you can see. You can have different signals. So there are a certain number of alterations linked to the state of health of the equipment that is being measured. So it may be linked to the state of health of the electrical part, so the electricity, speed drive, a stator that's damaged, or you can have alterations linked to the mechanical part of the system. And I'm going to go into details in the next slide. So everybody's saying, oh yes, it makes sense. You know, I realize that I can monitor the electrical health by looking at these signals, but for the mechanical side of things, for the bearings or alignments, so here's an analogy that we often use: the cyclist who has a wobbly wheel. So the cyclist will feel that the wheel is wobbly. So it's something that he knows is there, but he has to push a little bit harder with his legs, so provide extra torque. And this is what happens in a motor, basically. For example, if the machine is slightly off, it will have to provide higher torque. So that's what we're measuring in a very specific manner. So we look at high frequency and high resolution to do this. So on the next slide, as we will see, there's a whole range of different signatures that we are familiar with. That are pre-established. They allow us to identify the start of breakdowns like electrical signals. But if we continue, we can have mechanical signals and process signals for certain machines. So for example, here, if you look at the last part, we've got cavitation that can damage pumps. So the idea is to detect the precursor signals, so, you know, defects in bearings, for example, and then let the operator know, give them notice and give them the opportunity to organize maintenance operations, keeping in mind that there are some defects that can, you know, get worse very, very quickly. So that's the idea, that's the challenge that we wanted to tackle, to, you know, give a sliding rule for these different defects. So you've got a physical part, you've got the machinery, you've got three current transformers that are fixed around the power cables of the machine. And then in the electrical cabinet, you install an electronic box. It takes just 15 minutes to install. You don't necessarily have to stop the machine. It really depends on the machine. And then the box acquires current, and it processes the signals locally and then sends the information, sends the indicators to the web platform, our web platform. And this web platform is available to our customers. So the customer can view the state of health of the machinery, see how it's going, see what the trend is of the different health indicators over time. Some customers, and this is what we're seeing on the right-hand side of the slide, want this to be integrated into their own supervision system. So we're working on that subject this year. So we want to be compatible with as many platforms as possible, so that integration is possible, so that, you know, that we've got the right viewing interfaces, for example. So here's an example of this interface. So it's designed to be fairly simple to use. So we know what the machine is. There are gauges from 0 to 10, and they represent the state of health of some part of the machine. So there's a gauge, for example, for the bearings, there's a gauge for the stator health, and that gauge, if it goes into orange and red, that means that you have maybe short circuit problems, and that's something that has to be dealt with, you know, because you're going to have a flash and the motor will stop working. So the solution, if we just want to summarize things on the next slide, please. So it's fairly simple, this solution. It's easy to install, it's easy to use, and it can be used continuously on a machine. So we've tried to be fairly aggressive in terms of pricing. And this is so that we can monitor different machines at the same time belonging to the same installation. So on the next slide, we can see some of our references. So this is where we started. So big industrialists in different areas, transport, water management, wind farms. We gave that example at the beginning. Chemical industry. We're also working with OEMs that make rotating machines, electrotechnical machines. So this has made it possible for us to validate the overall project and put forward this, offer this kind of service to different installation operators. And today, we're beginning to work with the GRDF, the gas utility, and we're planning, well, with the next point of contact, Moritz, who will be speaking in just a few moments. So we've started a first rollout in these installations. What we're hoping for is different user cases. So if there's the start of a breakdown, an electrical breakdown, for example, with a flashover in a stator, we'll try and let the operator know ahead of time and say, okay, be careful. We're seeing some short circuits on the stator. There's something that needs to be changed. So if we extend that to the whole sector, certainly there will be economies of scale to be had. And of course, we have to know the details of each installation. But one thing is sure, if you have a production shutdown that lasts for several days, well, installing this kind of box will be very quickly amortized. So I'll finish now with the increase in a load factor of an installation. So this brings us to the sector. There are a certain number of installations that had a load factor that was high and that was due to go higher. And when it's increased, well, the organization in charge of the installation, in charge of operating it and maintaining it, is going to have to be very attentive to these machines that are working a little bit harder. And as in this context, our boxes can be a good solution for safeguarding the machinery, making things just a bit safer. So for those that want to produce more in the future, it's also a useful addition. So I've finished with my presentation. Please feel free to ask questions. I think you have to use the discussion to do that, the chat. Yes, that's right. So thank you for what you have presented. It was very clear. You talked about working with OEMs from industry. Are you planning to work with OEMs specific to the biomethane sector so that products are as perfect as possible, so that they can improve their products, so that they can, operate the boxes on their units? Yes, that's exactly it. So we want to distribute the solution, and we've got a method to do that. Today, we haven't yet got an OEM catalog for this sector, but we're trying to systematize the approach for OEM. So hopefully we'll be able to do work with this sector in the future. Let's take a compressor. Maybe we'll be able to offer the solution for the compressor that will be then integrated with the machine that's ready to use. Thank you very much, Mathieu. Pleasure was all mine. If you have a question, then please ask your questions using the chat. So I'm now going to suggest that Moritz joins us for the next part of the session. Moritz Quack, who's a metallizer, very much involved in different working groups of the AMF. So it's going to be interesting to have your testimony, and this will be the conclusion of the presentations for this session and the different subjects that we've been talking about. So have you been able to experiment with things on your own biomethane unit? Oh, thank you, Mickael. I'm sorry, the sound is very bad. The sound is very bad. I'm sorry, it sounds like he is speaking underwater. Moritz, I've got the feeling that the sound is truncated. Maybe you can move closer to your microphone or reconnect the device. It's a question of bandwidth, actually. Can you hear me all the same?
La bande passante. Très bien, merci. Donc, je disais, effectivement, exploitant d'unités de méthanisation depuis 2013.
So this is the testimony of an operator, so a member of the AAMF, so an agricultural methanizer in France. So we were able to have exchange and visibility and feedback. So I'll just give you some very quick examples. So some tools that have been identified now. So, for example, so we can have analytical monitoring of costs. We can have comparison indicators. This is very much based on procedures. The sound has been cut off completely. Moritz, I think we've lost you.
Alors, Mickael, on va essayer de le joindre.
Mickael, we're going to try and call him on the phone. Well, it might be a bit better on telephone, but the audio quality is really not good. But it would be interesting to have him because his experience is interesting. Is there another presentation, or perhaps we can answer some questions while we're waiting to contact him by phone? Well, let's see if there's anything. Well, I'd like to thank Jérémie. There were many questions for Jérémie, and you've taken the time to answer practically all of those questions, either directly or to all of the participants. So I think we've got some good answers there. I don't know whether Maxime is still with us. There was a question, a remark about preventive maintenance, a remark that says yes for preventive maintenance. So it's Lucie Dervieux. She says yes for preventive maintenance, but be careful if it's not done properly, it can be very costly. Which is, do you have anything to reply to that? Well, preventive maintenance, there are three types of preventive maintenance: systematic preventive maintenance, which we do at regular intervals, conditional preventive maintenance, where there's a threshold that's identified that can be detected and quantified. And then there's predictive preventive maintenance, where we analyze trends, where we look at feedback, we look at quality of oils, vibrations, temperatures. When we start, well, we try and follow a maintenance plan with a specific periodicity defined. So there's the manufacturer that often asks operators to check their sensors every day. Of course, you have to be realistic. You have to ask for things that are in line with the time available. But often maintenance is systematic. So then there's conditional maintenance, as I was saying, where you've got cursors, information, thresholds that must not be exceeded. So if you've got a manometer, for example, you need to know what kind of value you must not exceed. And so you can very often do too much preventive maintenance. So sometimes you don't set the right set points. You don't cut it off electrically before maintenance. And if you haven't made the machine safe, if you haven't safeguarded it, you can shut it off completely. You can get fingers trapped, etc. So it's very important. The lock off is very important. You've also got to have the right replacement parts. You can't just do DIY, especially on gas sites where, not all equipment, not all devices are suitable. And then you've got to be able to buy the parts that you've used up. You've got to make sure that things are cleaned. And then it's important to have some kind of logbook following what has been done. There we go. So this is what you were thinking. Right, very good. I don't know if there are any other questions or remarks. Have a look as well. Moritz is reconnecting, so he should be joining us in just a little while. So, Jérémie, there was also a remark about the cost of inputs that has doubled over the past 15 years and the potential of biomethane that's gone down to 60% compared with the beginning. I think that's more of a remark than a question. I think we've really gone through all of the questions in the discussion.
Ouais, Mickael, je peux peut-être répondre. Il y avait,
So, Mickael, perhaps I can answer remarks about the CO2 market. So perhaps I didn't express myself properly, but for us on the CO2 market, well, yes, there is a market, but you can see that there's additional demand in the Nordic countries. There's a greater demand for CO2 because there's less tension on CO2. There are price tensions. The availability is not in line with demand. So, it's not a question of valorizing the CO2, it's a question of finding the people who are going to consume that CO2 and perhaps new stakeholders, industrialists or farmers who are not necessarily seduced by the idea of using CO2. Yes. So in principle, they don't want to use it, but it's a question of finding the right outlets for it. Yes. With GRDF and Bastien Prat, we're going to try and launch a call for projects, notably in Brittany, to determine and identify local stakeholders who might want to consume CO2 and use CO2 in their methanization. Moritz, is the connection a little bit better? Well, the bandwidth should be better. Yes, the sound is much better. Very good. So this is, often what happens with IT. It's also what happens with the methanization units. Sometimes they don't work quite the way you want them to work. So where were we? We were talking about optimization tools. You were saying that it was fairly procedure-based, but it's important to set up procedures to really make sure that the installation is being run properly. That's right. Thank you for that reminder. So you've got to anticipate any unexpected events. The fourth point, guarantee that you've got nominal production, whatever happens. Well, there are many theoretical things, but in the field, things don't always work smoothly. So that's an important point. And the last point, make sure that you're not off spec, you don't have any drifts. Mickael, let's go on to the next slide. So the first point, make sure that you have analytical monitoring of costs. So cost accounting. This is not something that's done an awful lot, but what's important is to have some kind of table, a very simple table, where you look at the costs in detail, where you spread them out per item. So separate out purification, gas production, etc. And if possible, for the gas production part, go down to the transfer, the incorporation, the transfer, because the more details you have, the better idea you have where the problem comes from. So the second point was brought up by Jérémie, is the cost of inputs. I listened what Jérémie was saying. I'm not seeing any drop in input prices. There are specialists who have been out there in the market, who work in the animal feed market, and it's important to choose the right materials. It has to be methogenic. You've got to have material that is perhaps more costly than others, but has a better possibility of producing methane. So it's a bit of a paradox. So putting in a methanizer a product that has a very low dry contact, this will be different than using matter that's wetter. This will have an effect on the cost of spreading. If you've got a product that limits your spreading, then this is good for the upstream and downstream part of the process. So somebody who has 100-ton spreading for €1.55, €1.60 per nanometers cubed, there you're going to be paying 12 euros per cubic meter for sites that are decentralized, that are far away from the farms. It's 25 abroad. So the idea is to say, okay, my installation is profitable, but as we saw with one of the presentations, you've got to have, there's a critical size for installations. So I was going to say that it's important to look at these different aspects. The bigger your installation, you've got to double your inputs. You've got to look at costs. Sometimes, if you want to increase the size, you might have to go further afield to get your raw material. So if it's 40,000 tons and you're at 20 euros or even 10 euros, that's a big delta at the end of the year for the profit and loss accounts. And the last point is maintenance. So maintenance, you've really got to be careful about what is proposed by suppliers. You can sometimes have incredible maintenance prices that are not justified, and operators need to be able to understand how their machines work as well, so that they can ensure availability. And the last point, well, labor costs, this is similar to some of the other points, and outsourced services. Again, this is something that has been on a case-by-case basis. For some services, it will be better to call on an outside service provider than doing it yourself, because you waste a lot of time. And for others, you realize that for what it was, it cost an awful lot of money getting somebody in from outside.
Now, if we continue on the second point, which is to put together comparison indicators. Now that we've looked at the cost accounting side of things, let me just stress that we can go into more detail on this information. All you need is an Excel table that's ample, and you just put together your columns. You have a column per month, per year with other sites, and basically I look at my electricity bill. I note the number of kilowatts. I note what I've produced, how many cubic meters of methane I've been able to produce, and then I establish the ratios. I do exactly the same thing with my entrants. And on this table, I can also note down how often breakdowns occur. It's not just necessarily the machine, it can be different parts. And that way I have a figure for each month. And once you've got a bit more experience, you can basically compile all of this information per year. You can highlight which machines break down the most often, for example. And you can even use these figures to reassure the banks. It means basically that you've got a reporting system from one year to the next to analyze things and to see where the main costs occur. You might not see it from one month to the next, but you can see it from one year to the next, because you've got all the information. And you might not necessarily see the performance if you just analyze the information for a month or two, but you will see it if you compare 2018 with 2021, for example. And if you study all of the aspects, then you will get information and you can see whether the problems that you have, for example, are due to your membranes or due to other aspects. And you can always detect where there's likely to be a problem. I also perform comparisons with other sites. It's a bit more difficult because obviously you can't compare everything. Not everything is comparable. But typically speaking, we have discussions within our Farmers and Methanization Association, and the aim is to be able to put information on the table and compare on certain standard breakdowns. We can do it with our neighbours or we can do it with colleagues in other regions, but it's fantastic in that we just don't feel isolated. We've got data in our hands and we can see where there are potential problems with our installation. The last point I wanted to raise concerns the tool, the system that GRDF set up, and there was a person from GRDF that presented it earlier. It's a system that is available throughout France. It's called MethaCompare. It's an Excel file. I'm not going to make any money out of this, but I'd just like to say it's a very good system. It's very, very useful. It's the kind of table that is very useful for us as methanizers. It means that the more users know how to fill in this table with a lot of very basic data per month and per year, the more data we're going to be able to compile and the more we're going to be able to compare what we do throughout France. And as a result, if there are lots of users, we'll always have up-to-date information. So I think it means that thanks to the discussions that we'll have further down the line, yeah, it's just a fantastic tool that I believe should be developed further so that we can pinpoint the different areas where we can improve our installations. Now we're running slightly late, and we're going to have to give our participants time to have a break. So can we just take 5 minutes to conclude? Okay, I'll hurry ahead. It's very important to anticipate on unexpected events. Basically, what I mean by this is you need to have a checklist, a daily and monthly and weekly checklist, and very quickly you realize that when you look at your methanizer, once you've got experience, you can see if there's an anomaly. It's true also for what you listen to, what you smell. Preventive maintenance, you can do it with very basic tools. I've found solutions on the internet, cheap solutions, whereby you can have an alarm system to remind you to perform certain checks, and also preventive maintenance. That really is the key. All the time, it's important to have a stock of spare parts, because however good your maintenance contracts are, it's never going to be as quick as if you've got the spare parts on site for when you need them. Concerning the guarantee to the nominal production, I would simply say that it's very important to size your machine at 120% of the maximum that you're able to achieve. For example, you've got your entrance, you have to know that you're capable of producing more potentially than what your entrance can provide. Next, concerning your monitoring, your biological monitoring, it's important to do this on a regular basis, the pH and so on and so forth. You've got to look at your buffer capacity. It's very important from a biological perspective, particularly when you've got many different entrants, and it enables you to anticipate on potential breakdowns. When you've got really hefty maintenance work to do, make sure you do it over a 2-month period, not within the course of 1 month. That way you're not putting yourself under pressure. And one last point also, when you've got this table that I described, I think sometimes it's important to produce 105% of what you need, for example, so that you've got a bit of production in hand. Next, it's very important to have good capacity gas bags. You don't want to lose any gas. It has a cost, but I think you get return on investment very quickly because you're not wasting any gas, and you need to make sure that you've always got a plan B, as we say, that you can double up your equipment. It goes back to what Jeremy was saying in his introduction. Very clearly, this is one of the tools I think that enables you as an operator to sleep at night. You're a lot less stressed day in, day out. I don't feel pressure. I know I work 7 days a week. Very often I'm on my own, but the fact that I know that I've got backup equipment is extremely reassuring. Sometimes, if necessary, I can borrow equipment from a neighbouring farm. And also, it's very important to prevent drifts from occurring. We always say the devil hides in the detail. You might have a minor breakdown, you might be able to get around it, but make sure that you always work out where the breakdown came from, why it occurred, and make sure that you correct things. Also, when you forget the detail, you end up not seeing it at all, and that's where suddenly your neighbour turns up and said, "Oh, that's very strange that you didn't correct this minor detail. It could turn into a very big problem." Next, it's important to have the right measurement tools and also to set yourself limits as an individual, limits that you yourself will not move beyond. Going back to the measuring tools, you've got to be able to measure all types of pressure on your boiler, for example. There are some very basic tools that enable you to perform good technical maintenance management. And going back to the last point, make sure that you set yourself limits. I've done the sketch of the frog. Some of you are aware of this, but it's very illustrative. If you're unfortunate enough to look at your pH that is rising very gradually, very slowly, and if you think, oh, it's really not a problem, if you think it's not moving up very quickly, no, the problem is that if ever your pH, for example, gets down too low, you'll find it impossible to move it back up. So basically, don't be like the frog in the water who's loving the heat, but who's going to boil very shortly. I do apologize for rushing you along. It's just that we don't have much time left. Just a question. Do you know how many farmers at the current time have filled in the Excel file, I think he said, and what kind of targets do you have? Well, the targets that we've set for Metacomp are, well, there are about 10 methanizers today that have filled in the Excel document. We have a big partnership between the AMF and GRDF. In future, we want to have 50 or so in place by the end of the year. That's the target we've set ourselves within the association. This document, of course, is available to any user, any methanization user. Those who are interested can sign up. And if we've got 1,000 people filling it in the future, then that would be absolutely brilliant. Please note that it is anonymous, isn't it? Yes, absolutely. So anybody and everybody can take part. And as I said in the introduction, it's anonymous and it's all the questions are very specific, and yeah, it really does stay anonymous. And the aim is to detect anomalies and to be able to reduce inefficiencies or excess costs. Yes, thank you very much, Sylvain. Thank you for your feedback. It's excellent to see how much knowledge, how much know-how you have in relation to methanization. And you said very clearly how important it is to have all the right tools and to receive support from the professionals, sometimes from all around the setup. So I suggest that we conclude very quickly because we need to give everybody a quick break before we continue with the next session that is scheduled to start at 4 p.m. Thank you to all of the speakers who are here with us this afternoon. Thank you for taking time to come and join us, and thank you for having prepared all of your presentations. Thank you to Pascal from GRDF, who was in the shadows here, but who helped me to organize this conference. Thank you for everything, and the broadcast will be available very shortly to you all. Thank you once again. Thank you for all the questions that you've put. I think we've managed to answer most of the questions, and we look forward to seeing you in flesh and blood, hopefully in the summer. We'll inform you very quickly of what's currently being prepared. Thank you once again, and see you soon.
Merci.
Au revoir.